Okay, we're going to look at a cubic equation, and it's an exam type question. In fact, all these questions come exactly from an exam. I've modified it a little bit, and I made a different function up here, but it all works out, and let's just give it a try. The function is f of x equals x minus 1 squared times x minus 3, and they've even given us if we multiplied this all out, we'd get x cubed minus 5x squared plus 7x minus 3. This is called intercept form of a function, and this is called standard form. We use the standard form to get the derivative and the second derivative, but we're looking at the x-intercepts here. Okay, let's just try this. Now the first question is, write down the intercepts of the function, calculate the stationary or turning points, and then to sketch the graph. And we're just going to go through that. What does this look like? Well, the first one, to find the y-intercept, you just let x equals 0 right here. All of this becomes nothing, and y is minus 3. So if x is 0, if you put 0 in there, you'll get minus 3 out for y. You just have to try it yourself. But it's really nice when it's in this form, x minus 1 squared, because whatever you put in here will make this 0, will make y or f of x 0. So x equals 1 is an x-intercept. And notice that if it squares here, if you have x minus 1, it'll turn right there. It'll just touch the x-axis there. That's good to know. And the other number that would clearly make it 0 is 3 minus 3 is 0. So 3 and 0. So there's your two x-intercepts, 1 and 3, and your y-intercept is minus 3. Those are the intercepts. Now they say find the turning points, find the stationary points. Well, to do that, you have to take the derivative. And so you do that thing, 3 times multiplying it in front, 3x squared, 2 times minus 5 is minus 10, and bring it down 1. 1 times 7 is 7, and x to the 0 is just 1. In fact, that's a linear equation. 7x, the gradient just stays 7. It's one number 7. Now, what you have to do is a stationary point, the gradient, and these derivatives tell you the gradient for any x value. At a turning or stationary point, the gradient's 0, so that's why you let it equal 0. And then you just factor it. 3x times x gives you 3x squared. 7 times 1 is 7. And the only way to make this work is minus 7 times x is minus 7x. 3x times minus 1 is minus 3x. Minus 7x and minus 3x gives me the minus 10x. You could put this into the quadratic formula, a, b, and c, and you'd get two answers out. X is 7 over 3 or x is 1. Well, those are the x-coordinates of your turning point. And all you do is take 7 over 3 and put it back in for x, and put it in your calculator, and you'll get this weird number, a little bit bigger than negative 1, negative 32 over 27. You could write it as a decimal. But if you put 1 in, we already know if we put 1 in, you put 1 into this function, 1 minus 1 is 0. You get 0 out. So there's your turning points. Now, the problem is, for a bunch of marks, is just to sketch this graph. Well, put in your intercepts first, minus 3 for the y-intercept, x-intercept of 1, x-intercept of 3, the turning point as a 1 and 0, and then 7 over 3 and minus 32 over 27. It's somewhere a little bit bigger than 2 and somewhere a little bit smaller than 1. You don't have to be, I got a computer, I cheated and made it perfect, but you just have to make a curve like this, the basic curve that goes up like that, and just make it a reasonable sort of thing. And that's it. There's your turning point. And that's the first 3 questions. I'll make a video of doing the last 3 questions in just a bit.